Hi guys. So in my previous class we learned about how to add vectors by head and tail method. Suppose if I take one vector at here randomly in the x and y plane, and I have taken one more vector. So here I can change its direction. So let it be in this direction. So if you can see, this vector magnitude is showing at here as 20. And if I can touch a vector's magnitude is showing as 10. Now if I can check as sum, here I'm having an option sum. So if I can click on sum again, now it is not added by itself. Suppose if I click on it, it adds by itself. How I got sum s is the blue vector. So here we are adding the head to tail. So first vector head, I am bringing the second vector tail. Now that to the two vectors. Suppose if I bring the sum vector again back, now this is exactly matching. Now we can write that s equal to a bar plus b bar. Now this is how we can add the vectors. Suppose if I take one more vector, so here I am having one more option. Let me take the vector c. Now if I can take out sum for a moment, what could be the resultant? Now this third vector c vector we need to bring to the at here. Now let us take my sum. Yeah, here you can see the resultant s equal to, now three vectors are added, a bar plus b bar plus c bar. So likely we added the vectors head and tail method. Now later that, suppose if we are having vectors, let me clear this first. So let me take two vectors. So this is vector a and vector b. Let me take this vector, a small vector. Now if you can take the sum, so the sum of the two vectors, so if you can take this at here and if you can bring this at here, now this vector is exactly matched. Now if this is our vector, s is a vector, so this vector is formed because of a and b. Now this vector is resolved into two components. That two components are these two, a bar and b bar. So this is how we resolve vectors into components. So let us understand that in deep, how the vector resolution takes place. Suppose if we take a vector, a single vector, so any vector is resolved into two components, its horizontal component and its vertical component. So here I am having option. So this is a vector horizontal component along on the x-axis and vertical component along on y-axis. Or if you take, here I am having an option resolution of vectors. Now these dotted lines, so these dotted vectors are the resolution of vector A. So we can say that the vector is resolved. These are the resolution vector. These two are the resolution vectors. Or let us do one action before that. So let me shift this at here. First I will take the two vectors along the x-axis and along the y-axis. Suppose this vector is at here, is at 20. Let me switch off. Yeah. Now if I take a c vector, at here. Now what is the resultant vector? Now if I can give the resultant vector, yes, s is at come here. Now the s is the resolution, the s vector form. So this is formed, s is formed because of b and c. Or in opposite also you can say the s vector is resolved into two components. How it is? One is horizontal component, so this is horizontal component, and this is vertical component. So any vector is resolved into its components in two-dimensional plane. So in 3 dimensions, it resolves into 3 components. The z-axis also will be coming into the picture. So any vector in 2-dimensional plane resolve into 2 components. One is its horizontal component and one is the vertical components. So if this is a vector, the given vector is a vector. For a moment, I am considering this as a vector. Now this is resolved into 2 components, so this I can call as ax, horizontal component, and this we call as ay, vertical component. If a is a vector, obviously ax is also a vector and ay is also a vector. How do we represent ax vector? So I want to know what is the value of ax and what is the value of ay. And here you remember that ax and ay is formed from a. So these two form from a itself only. So to find out ax and ay, so here our early knowledge of trigonometry is helpful. Suppose this is a, if you can take as a vector. Now here you are seeing a right triangle. So a right triangle, here if you can take angle theta. Okay. Now if I write from this right triangle, what is the expression for cos theta? Cos theta equal to base by hypotenuse. Here base value is equal to how much? Base value equal to ax bar. By hypotenuse what is it called? A bar. And cos theta comes as it is. So now ax vector equal how much? A cos theta. See, we got ax vector in terms of a. Now I can write ax vector equal to how much it is? A cos theta. This is how simple it is. And let me try to get another vector ay sin theta. To get that, now this time I am taking sin theta. What is sin theta ratio? You can write that perpendicular by hypotenuse. So sin theta equal to, what is the perpendicular value at here? Here it is a y bar. What is hypotenuse? Here itself a bar itself. Therefore a y vector equal to how much it is? A vector upon sin theta. So this is how we got the resolution of vectors. Now here I am going to change one small change. I am dropping direction. So this is just I am writing its only magnitude. So for magnitude we can use modulus. Later I can tell about how to get the direction. Now finally I can say A vector is resolved into two components. It's a horizontal components and its vertical components. If A is a vector, what is the horizontal component we shall take? That is A cos theta. And what its vertical component we can take? That we can take as A sin theta. So a vector is resolved into two components, its horizontal components and its vertical components in two-dimensional plane. Now, in horizontal components, that vector we can write as ax equal to a cos theta and ay equal to a sin theta. Now, how to find the direction of the vector? Now, if a bar is the vector, so that vector is resolved into two components in making an angle theta. To find the direction, again here I am taking the trigonometry help. Now here I got that ax cos theta for magnitude and here I got that ay sin theta. Now from the same right triangle you can give the value of tan theta. So what is the tan theta you can write? If ax is component and ay is component, what is the tan theta you can write? Perpendicular by base. Tan theta equal to perpendicular by base. Now tan theta, here perpendicular value equal to how much? Ay. Only magnitude we have to take. And hypotenuse, sorry, it's a perpendicular by base. I supposed to write here it is base. And here the base value equal to ax. Now if you divide that ay upon ax, magnitudes only. Okay, now we can get tan theta, so that theta gives the direction of the vector. So this is how we find a vector magnitude and direction and its resolved into component terms. So this is a method in triangular vector addition since forms a triangle. And before that, so here I would like to mention very important components. This is one of the fundamental. So that fundamental, here it is. We know that this is x-axis and this is negative x-axis. X-axis in vector should represent direction. Okay, and similarly this is a positive y-axis and this is negative y-axis, and it should represent that corresponding direction. And if you take third axis as z-axis, it's also having. Here it is two-dimensional plane. It's hard to represent, but I will represent it later. So here I am introducing unit vectors along these directions. Unit vectors. How you define a unit vector? Unit vector means a vector, suppose a bar is a vector, upon its magnitude we define as a unit vector. Okay, so this is a standard definition of unit vectors. Vector upon its magnitude we define as unit vectors. But as a standard, as a basic, there are the unit vectors in x and y coordinate system. In x-axis, we can represent I cap is a unit vector. So its I cap represents the direction of that particular. And we can represent j cap in the y-axis direction. So here these two are the new unit vectors along x-axis, along y-axis. Similarly, in the negative x-axis, we will represent that minus I cap is a unit vector. So this unit vector having magnitude only 1. Its magnitude a unit. Unit means 1. Similarly, in negative y-axis, unit vector equal to minus j cap. Why I am introducing these unit vectors? Because in the later session we won't write vectors in a diagram. Suppose this vector is in this diagram. Now this vector I can represent in terms of components. Now this vector we need to write in the equation. What is the a bar at here? A bar we have to write in terms of some equation. Always it is not possible to draw a diagram at all. Now a vector can resolve into two components, that is ax I cap plus ay j cap. Here ax gives the magnitude of the unit vector, magnitude of the a vector along the x-axis, and ay gives the magnitude of the a vector along the y-axis. Yet here if you can see on the scale, ax magnitude how much it is? Here it is on the scale. Since it's scale, we can write directly from there. So to make clearance that, I can rub on this. Now from here you can write that a bar equal to the equation of this vector representing in terms of equations. So this is a bar equal to how much it is? 10 I cap and plus ay also if you can measure, that is also showing at 10 j cap. Now this is a diagrammatic representation of a vector and this is equation representation of that vector. I hope you got that meaning. Now here a vector should represent magnitude and direction. So in this given equation, 10 represents the magnitude of the vector component along x-axis, and I cap tells about this component is along x-axis. Why? Because I vector is unit vector along the x-axis. Similarly, if you can take 10 j cap, 10 j cap, 10 represents the magnitude along the y-axis and j cap tells about the direction. Yeah, this component is along the y direction. So to represent vectors in terms of equations, so these resolution of vector components and along unit vectors, they are very helpful. Yeah, let's try some other. Suppose if I take a vector, so let me take randomly. Let me increase this. Now to this vector I added another vector. Now let me take the sum. Now this is the sum of the vectors. Now this sum I got by placing head to tail. Now if you closely observe, if I can take here, I am having options as taking values. Now I have taken values. So a vector magnitude representing 28.3 and b vector representing exactly 10. On the scale you can see here 20 up to 30, so its magnitude equal to 10. It's the only magnitude, that's why it's representing bar. And the resultant vector, the blue vector, dark blue vector, sum, also showing magnitude. How a vector magnitude can find? So that we already tried. If a vector is made up of two, a bar and b bar, to find its magnitude r, we're using a formula r equal to square root of a square plus b square. So this is the formula we can use. Right now I am not talking about this magnitude because I don't want its values. but I was concentrating about resolutions. Now let me take resolution of vectors. So let us see first resolution of vector, how this vector resolution has taken place. For a moment, if I take out sum, so if I take out sum, the resolution of a vector, so a vector is resolved into two components, horizontal component and vertical component. What about the b vector resolution? If I can get option, the resolution for b vector, so b vector resolution is not showing it here, so let us continue like this. And we know how to resolve this component. Now since b vector is only parallel to parallel to x-axis, it do not have any component along the y-axis. It's a common sense. Now if I take sum, now if you can observe, sum also having components along x-axis and along the y-axis. If you can closely observe, the sum is combined at here with the two components. On along x-axis, if you can see, this is one of the arrow mark which is component along x-axis, and this is another part of arrow mark that belongs to b bar vector. And similarly, in the y-axis also, it's having components. Now I have to concentrate on the result. Now this is the y-axis component. Now here the resolution of vector is also, the resultant vector is also resolved into two components along horizontal component and vertical components. Yeah, how can I represent this resultant vector in equation form? In equation form, on x-axis it is showing up to 30. So the resolution S bar equal to 30 I cap. I cap is unit vector along x-axis. Plus, and what about the J cap? J cap, it is representing up to it here. Maybe if I just move this to little up, it is showing up to 20, so I can add that 20 J cap. So this is how we write the resolution of vectors. And to find the direction at here, so to find the vector direction theta, if I can take the horizontal component that equal to 30 I cap and vertical component 20 J cap. Now theta equal to, how much you can write? 20 upon 30. Only its magnitude you have to write, tan theta. So this is supposed to be tan theta. Tan theta equal to 20 upon 30. So then we can get that direction of the resultant vector. So this is how in two dimensions we represent. It's only for two dimensions to represent the vector's resolutions into its corresponding components, horizontal component and vertical components. So here I introduced two new things, that is known as unit vectors. So I cap is unit vector along x-axis and j cap is unit vector along y-axis. Now let us try to learn in the next class about vectors in 3 dimensions. I will continue that in my next class.